Hello everyone. My name is Rahul Konodia, Assistant Professor at Department BSc Computer Science from IMT College of Science and Technology, Greater Noida. So today we are going to discuss about data structure with C. Before proceed to the data structure, we have to know about what is data. Basically, data is a small piece of information that we use every day. It can be anything like words, number, picture, or even sound. We can keep this information on a paper or in electronic device like computer or phones. Basically, data is a piece of information, or we can say data is a collection of information. Anything which gives information is known as data, like any number, words, pictures, even sounds. These are data, or anything which is written on a paper or in electronic device like computer or phones. All these are data. Suppose you have a list of your friends, or you have scored something in a game, or whatever you have scored in a game. All these are data. Your phone number, your roll number, your name, all are these data. So going to the next point, what is data structure? Our data structure is a way to organize data so that we can easily see how different pieces of data are connected to each other. It is like a map that shows the relationship between different pieces of information. Basically, data structure is a way to organize data that we can efficiently modify and access, or we can see that how much what different types of data are connected to each other. Or in other words, we can say that data structure help us to arrange and store data in a way that make it easy to understand and work with, considering both the data itself and how it linked together. Basically, data structure is help us to organizing data and that arrange that we can easily work on that data and see that which data are linked together. Now, next point is, what is algorithm? An algorithm is a set by step procedure or a formula for solving a problem or performing a task. Basically, algorithm is a step-by-step procedure, or we can say formula to solve any problem or perform any task. In context of computer science, algorithms are the backbone of all the programming and used to manipulate data, make decision, and solve complex problems. Basically, in computer science, we use algorithm for our programming, which also make decision, which also help in solving a complex problem. An algorithm take an input, process it through a various series of well-defined steps, and process an output. Basically, an algorithm takes input and it process many several steps and then proceeds then produce an output. Now going to the next topic, which is data structure are normally divided into two broad categories, that is primitive data structure and non-primitive data structure. Now talk on primitive data structure, which is further divided into many categories like integer, float, character, and pointer. uh, Now we have to talk on non-primitive data structure, which is divided into two parts, which is linear list and non-linear list. uh, Talking on linear list, which is array, linked list, stack, and queue. All these are linear lists, which we can say sequential in order, and non-linear list are graph and tree, which also we can say that they are non-sequential in order. Now we can see primitive data structure. What is primitive data structure? Basically, primitive data structure are the most basic type of data structure which is directly supported by the programming language, which was already predefined in the program. For example, integer, int, char, float, double, all these are primitive data structure. Now we move to non-primitive data structure. Basically, non-primitive data structure are the most sophisticated data structure, or we can say that most complex data structure. These are derived from the primitive data structure. Non-primitive data structure emphasizes on structuring of a group of homogeneous. We can say same type of data structure or heterogeneous, different types of data structure, different types of data types or data items. Non-primitive data structure are array, linked list, stack, queue, tree, graph. All are non-primitive data structure. Now, design of an efficient data structure must take an operation to be performed on data structure. There's several operations performed on all these data structure. These are insertion. Adding a new element to the data structure means we can add new element in data structure, that is insertion. Now, next is deletion. Removing an existing element from the data structure. We can say that we can delete or remove any any data element from data structure which already existed in that data structure. Traversal. Accessing each element in data structure sequentially means to access each element in data structure sequentially, that is called traversaling. Searching. Finding an element based on a specific key. If there is any condition or we can say specific key to find an element which is also in searching. Sorting, arranging elements in a specific order which is descending or ascending. Merging, combining two or more data structure into one, that is called merging. Means combine one or more data structure, that is called merging. Updating, modifying an existing element in data structure. We can modify any element in our data structure, which is also known as updating. Create. To initialize new data structure is known as create. Destroy or delete. Delocation of memory or removing the entire data structure. We can say to delete entire data structure is also delete or destroying the data structure. All several operations are performed in data structure. Now we can see complexity and time speed trade-off, in which we can see time complexity. What is time complexity? Basically, time complexity tell us how long an algorithm will take to finish based on the size of input data, usually shown as n. Basically, time complexity tell us that how an algorithm takes when and how much time it will take based on the size of input. It helps us to understand how algorithm speed changes as input get bigger, and also analyze that how much algorithm speeds changes if the input is bigger. The common notations are big O1, which is constant time. The algorithm speed does not change no matter how big input is. In the constant time, the algorithm speed does not change. It doesn't matter that input size is smaller or bigger. Big O n, which is linear time. The time it takes grow directly with the size of input. In linear time, the times grows directly by the size of input. Basically, if we take in bigger input, then it will take long time. Then big of n square, which is also quadratic time. The execution of time grow quadratically as input size increases. Means the execution time grow uh, quadratically as input size is increases. For example, bubble sort algorithm, where each element is compared with every other element. Now, space complexity. Space complexity tell us how much memory an algorithm need based on the size of input. Same as time complexity, where in time complexity we have talk about time, but in space complexity we have to talk about memory storage. Uh, complexity tell us that how much memory space an algorithm needs based on the size of input. It includes the memory used for a variable, data structure, and extra space the algorithm uses. For example, if there is bigger one space, then the algorithm uses a fixed amount of memory regard of a input size. Similarly, if the space complexity is a big of one, then we can say the algorithm is a fixed amount. The algorithm uses a fixed amount of memory, whether it does not affected by the input size. But if there is a big of n space, then the memory uses grow linearly with the input size. In big of n space, the memory basically uses grow linearly with variance in the input with variance of input size. For example, storing an array of an element. Now talk on time space trade-off means the time space trade-off means that when we try to make an algorithm faster, it might be use more memory, and if we try to save memory, it might be take longer to run. Basically, time space trade-off means to balancing time complexity and space complexity means if we try to make algorithm fast, then it consume more memory. But if we want save memory, then it will take longer time to run the algorithm. For example, caching. We store results in a memory using more space so that the program run faster. That next time it will need those results. And loop unrolling. Now we see array. What is array? Basically, array is defined as a set of finite number of homogeneous element or a same data item. Basically, array is defined as a finite number of homogeneous element, means same data types. We can say same data types or same data items. It means an array contain one type of data only. Either all are integer or all are float point number or all character. Basically, it contains only one data types. Either all are integer, all are float, or all are character. How to declare an array? We have see the first we took data type and then a variable name and the size of array. As given in example, where int specify the data types or type of element of array stores, and AR is the name of array, and the number is specified inside the square bracket is the number of element an array can store. This is also called size or length of array. In a square bracket, we have declared the size of array, or we can say length of array. As given in a diagram, array index always start with the 0, and then sequentially it grows 0, 1, 2. And array elements are in array blocks, as we can see. For reading an array, we have used one loop. For writing an array, we have used one loop, but for in one dimensional array. But if we are reading or writing two-dimensional array, it will require two loop. Similarly, if the array of n dimension, it will require n loop. So from this point, we understand that if we are reading or writing in two-dimensional array, it will take two loop for reading or writing. Similarly, if there is n dimension array, it will require n loops. To calculate memory address calculation in array, to computing the memory address of an array element based on its index. So basically, to calculate the memory address in array, it is basically based on its in elements based on its index. The formulas are given that address to find the address that is equal to base address plus index into size of element. To find the address of an array element, start at the base address of the array and add the product of an index and size of each element. We have also take example where base address is given, also index position is given, and the size of each element is given, which is 4 byte. We will put all this information in formula and we'll get the types of array. One dimension array. The simplest type of array, one dimension array, contain single row of element. These array are usually indexed from 0 to n minus 1, where n is the size of array. Basically, when we talk about 1D array, then it is known as a single dimension array, or in which we can use only one subscript to define the elements of array. How to declare a one dimensional array? The syntax is given that we use data types and then array name and then size of array. Where data types is a type of data of each array, and array name is the name of array which we can refer it. Array size is the number of block of a memory array is going to have. As given in a figure, we have declared 5 size of array followed by data types and array name, where index is started from 0. Now we see two-dimensional array. Two-dimensional array are a type of array that contain array elements. These are also referred to a matrix array since they can be true of as a grid that lay out of the elements into row and column. Each element within the two-dimensional array can be accessed individually by its row and column locations. Basically, two-dimensional array is used two subscripts, that is row and column, to represent row value, and a second subscript to represent column value. It is mainly used for a matrix representation. Syntax for declaration of 2D dimensional array, that is data types and then array name, and in the first square bracket the size of first dimension, and the second square bracket the size of second dimension, where data type is the type of data of each array block, and array name is the name of array which is used to which is we can refer to it. Size of dimension is the number of block of memory array is going to have corresponding dimension. As we have declared two dimension array, the row is 5 and the column is 10. And also data types is integer and the array name is nums. Now we have to talk on sparse matrix. A matrix is a two-dimensional data object made up of m rows and n columns. Therefore, having total m into n values. If most of the elements of a matrix is zero value, then it is called sparse matrix. Basically, a matrix is made up from the two-dimensional array where m is row and n is column. If we talk about sparse matrix, then if the most of the elements in a matrix is zero value, then that matrix is known as sparse matrix. So in instead of simple matrix, why we use sparse matrix? So it's first of all it's for the storage and for the computing time. For the storage, if there is a lesser number of zero element than zero, thus the lesser memory can be used to store only those elements. Basically, if there is a lesser non-zero elements as compared to zero element, does it take a lesser memory to store those elements? And for the computing times, if the computing time can be saved by logically designing a data structure traversing only non-zero elements. For computing time, without wasting time to traversing on a zero element, we only traverse to the non-zero element. It's also save the time. As we have given a diagram of a sparse matrix, there is a maximum zero element as compared to the non-zero element. Representing a sparse matrix by 2D array led to the wastage of lots of a memory, as the zero in a matrix are no use in most of the cases. So instead of storing zeros with the non-zero element, we store only the non-zero element. This means storing non-zero elements with the triples, row, column, and value. Basically, in uh, Spark matrix by 2D array, which is a wastage of lots of memory because there is a lots of zero in a matrix which have a no use. So instead of storing zeros with non-zero element, we store only non-zero elements. This means we store storing non-zero element with triples, which is row, column, and value. Spark matrix represent can be done in the following ways. That is, two common representation is a array representation and a linked representation. First method is using array. 2D array is used to represent a Spark matrix in which there are three rows named as a row, column, and value. Rows. If we talk about rows, the index of row where non-zero element is located. In row, we take index of the row where non-zero elements is located. In column, index of column where non-zero elements is located. In column, we take index of a column where non-zero is located. And for the value of non-zero element is located at an index of a row and column. We took value of non-zero element from the index of a row and column. From the given figure, as you see in the first row is zero, where row is zero and column is second. Column second, where row is zero and column is second, the value is 3, as given in a first row of matrix. Uh, Further, we can solve all this matrix by this figure. As we look at this figure, time complexity for this Spark matrix using array is big O and M, where n is the number of row and in Spark matrix and m is the number of column in a Spark matrix. For auxiliary space, it's take big O and M, where n is the number of row in a Spark matrix and m is the number of column in a Spark matrix. The second method using linked list. In linked list, each node have a 4 field. These 4 fields are defined as a row, column, value, and next node. In row, index of a row where non-zero element is located. Means if it takes index of a row where non-zero element is located. In column, index of a column where non-zero element is located. We took index of the column where non-zero is located. For the value of a non-zero element located at the index of a row and column. We took the value of where non-zero elements is located by the index of a row and column. And next node, the address of a next node is given. From the figure, we understand the first block in linked list 0, which represent the index of row 0, and the second is in second the index of column is given, which is 2, and at the place of 0 index, and the second column in second index of second column in column second index, the 3 non-zero elements is located, which is we declare, which we write. Now we have to talk on stack. Basically, stack is also a ordered collection of element like array, but it has a special feature that deletion and insertion of element can be done from one of in that is no top of stack. Due to this property, it is also called as last in first out types of data structure. It could be true of a just like a stack of a plate placed on a table in a party. A guest always take off a fresh plate from the top, and then new plates are placed on the stack at the top. It is the non-primitive data structure where element is inserted into a stack or removed from the stack. Its base remain fixed where the top of stack is changes. So basically, stack is a non-primitive linear data structure where it is a also order list in which addition of a new data and deletion of already existing data is done from only one name, which is top of stack. The last element will be the first to be removed from the stack. This is the reason it follow the principle of LIFO, means last in and first out. Insertion of element into stack is called push, and deletion of element from the stack is called. Basically, the operation of insertion of an element in the stack is called push, and deletion of an element from already existent in stack, which is called pop. The below show figures how operation is take place: push and pop. Notation of a stack. There are three notation to represent arithmetic expression, that is infix notation, prefix notation, and postfix notation. Infix notation are the convenient way of writing an expression in which each operator is placed between the operands. Infix expression can be parenthesized or unparenthesized depending upon the problem required. Basically, infix notation is the convenience way to writing an expression. Basically, in infix, we write operators in between the operands. For example, A plus B, where A and B is operand and plus is the operator, which is placed between operand. All these expression in infix notation because the operators come in between operand. Prefix notation. Prefix notation places the operator before the operand. This notation was introduced by the Polish mathematician, and it is often referred as a Polish notation. Prefix notation we also called Polish notation because it is given introduced by the Polish mathematician. So we have also called this Polish notation. In prefix notation, we place operator before the operand. For example, plus AB, where plus is the operator and AB is the operand. And also we see example minus CD, where minus is the operator and CD is the operand. Postfix notation. Postfix notation places the operator after the operand. This notation is just the reverse of Polish notation. It's also known as a reverse Polish notation. Postfix notation is also known as a reverse Polish notation. In postfix notation, we write operator after operand. For example, AB plus, where AB is the operand and plus is the operator. CD plus, where CD is the operand and plus is the operator, which is right after operand. All these expression in postfix notation because operator comes after the operation. As given in the table, how to convert arithmetic expression into this various notation. Thank you so much.